Study Designs in Pharmacoepidemiology, Quasi Experiment Part 2. Learning Objectives. Recognize multiple types of quasi-experiments. Identify advantages and disadvantages of a quasi-experiment. What are the different quasi-experimental study designs? Quasi-experimental design without control group, which is the weakest design. Quasi-experiment designs that use control groups but no pretest. Quasi-experimental design that use control group and pretest, and interrupted time series designs. The quasi-experiment design without control groups. So in this design, we have one group post-test only design. So please, you need to understand the notation used in quasi-experiment. So X means the intervention. O is the outcome variable. This notation is continued throughout the rest of the handouts. So we have intervention and we're comparing the outcome variable post-test, after the test. This is the weakest design. In this design, the intervention X is implemented and a post-test observation O1 is taken. For example, X could be introduction of a pharmacy order entry intervention, and O1 could be the pharmacy cost following the intervention. This design is the weakest among all quasi-experimental designs. Without any pretest observations or a control group, there are multiple threats to internal validity, including confounding variables. The second design is the one group pretest post-test design. So we have the O1 is pretest, X is the intervention, and O2 is the post-test measurement or the outcome. This is a commonly used study design. A single pretest measurement is taken, an intervention is implemented, and a post-test measurement is taken. In this instance, period O1 frequently serves as the control period. So you can think of it as its own control. So before the intervention is the control, after the intervention is the outcome or the cases. Okay. For example, O1 could be pharmacy cost prior to the intervention, X could be the introduction of pharmacy order entry system, and O2 could be the pharmacy cost following the intervention. The including of a pretest provides some information about what pharmacy cost would have been before the intervention. The third design is the one group pretest post-test design using double pretest. So in this example, we have double pretest and one post-test. The advantage of this design is that adding a second pretest prior to the intervention helps provide evidence that can be used to disprove other alternative explanation. You can think of it very similar to case control study. If you remember, we said that if we have more controls or more control groups, this will add power to the results. The same is here. If we have different or more than one pretest, this will add to the power of the conclusions. For example, in a study where a pharmacy order entry system led to a lower pharmacy cost, for example, O3 was lower than O2 and O1, if one had two pre-intervention measurements of the pharmacy cost and they were both elevated, this would suggest that the decrease in the cost was related to the intervention and not to the confounding. We have also this design, a quasi-experimental design that use a control group but no pretest. So we have a control group. So we have the intervention. We compare post-intervention. However, we compare to a different group, a control group, not to a pretest. Okay. Suppose that pharmacy order entry system was implemented in the medical intensive care unit in the MICU and not in the surgical intensive care unit. O1 would be pharmacy cost in the MICU after the intervention, and O2 would be the pharmacy cost in the surgical ICU after the intervention. The absence of a pre-test makes it difficult to know whether a change has occurred in the medical ICU. Also, the absence of pre-test measurements comparing the surgical ICU to the medical ICU makes it difficult to know whether differences in O1 and O2 are due to the intervention or due to other differences in the two units, confounding variables. Quasi-experimental design that use control group and pretest. This is a strong design. Again, the intervention is not randomized. The control group choosing a comparison group, obtaining a pretest measurement on both intervention and the control group allow for initial comparability of the groups. The assumption that if the intervention and the control groups are similar at pretest and the smaller likelihood that there is of important confounding variables differing between the two groups. This will add to the validity of our conclusions. So as you can see here in this notation, this is the notation, we have pre-test 1, pre-test 2, intervention, post-test, compared also to a control group where we also have measurement in the same time period, O1, O2, and O3. This is a very strong design. This design usually associated with better causal inferences that is almost similar to RCTs. However, again, it's not the major defect in Quasi experiments is the lack of randomization in this design. Untreated control group with dependent pretest and post-test sample. The use of both pretests and a comparison group make it easier to avoid certain threats to validity. The two groups are non-equivalent. Assignment to the groups is not by randomization, so still some bias may be introduced. Selection bias exists when selection results differences in unit characteristic between conditions and then may be related to the outcome differences. Example, suppose that a pharmacy order entry intervention was started in the medical ICU but not in the surgical ICU. If pre-intervention pharmacy cost in the medical ICU, O1A, and pre-medical intervention costs were assessed in the surgical ICU, O1B, are similar, it suggests that it's less likely that there are differences in the important confounding variables between the two units. This is very similar to RCTs when we compare baseline characteristic. We start with baseline characteristic comparing intervention group versus the placebo group, and we hope that we don't see any differences. If there is at baseline there is no differences, this by default means eliminating confounding variables, so any changes we will see later could be highly attributed to the intervention of interest. If medical ICU post-intervention cost O2A are less than pre-intervention, okay, in the medical ICU, but surgical ICU costs are similar, this suggests that the observed outcome may be causally related to the intervention. So if we see a change in the medical ICU cost before and after, but not in the surgical, so this could be highly attributed to the intervention itself. The last type we will talk about in this slide is the interrupted time series design. So you can see we do multiple pre-tests and multiple post-tests. We have 1, 2, 3, 4, 5 intervention here, and then we have post-test different 06, 07, 09, and 010. Interrupted time series design is the one in which a string of consecutive observations equally spaced in time is interrupted by the imposition of a treatment or intervention. The advantages of this design is that with multiple measurements, both pre and post interventions, it's easier to address and control for confounding and regression to the mean. Also, this design can be further strengthened by incorporating many of the designs featured previously, such as removal of the treatment, inclusion of a non-independent outcome variable, or addition of a control group. This will add to the strength of this design. Example, a pharmacy order entry system O1 through O5 could represent monthly pharmacist cost pre-intervention, and O6 to O9 monthly pharmacist cost post-intervention of the pharmacy order entry system. What are the strengths of Quasi experiments? Quasi experiments are reasonable alternative to randomized clinical trials, useful where pre-test selection and randomization of groups is difficult, saves time and resources compared to experimental designs. Weaknesses, non-equivalent groups may differ in many ways, including differences between treatment conditions, severity of illness, which introduce bias. Non-blinding allow to the possibility of unintended intervention. Blinding can be used in some quasi-experimental designs. Must document participant characteristics extensively to adjust for the confounding if present later. Potential biases of sample must be acknowledged when reporting findings. Causal inferences are weakened by the potential for bias versus experimental designs, which leave RCTs on the top of the pyramid of medical evidence because they are a strong design.